For the next several weeks, NASA's Operation IceBridge will have not one, but two campaigns surveying polar ice, one in the Arctic and one in the Antarctic. Both missions will measure the ice using a laser altimeter and a photographic mapper, and both will be flying on smaller, faster aircraft than usual. The Antarctic campaign will be timed to provide an annual snapshot of the region after the winter accumulation of snow and ice. IceBridge flew a similar Arctic campaign last spring out of Greenland, but for the first time is returning north for a post-melt season campaign as well.
So now that the summer has progressed, the snow has melted, ice has melted, we're going back right at the end of this melt season, hopefully before a lot of snow begins to fall, and then by surveying it again, if we see that the surface lowered a certain amount, that tells us, well, how much snow did we lose? How much ice did we lose? We can tie this in with what are called surface mass balance models.
IceBridge will be using a G5 aircraft from the National Center for Atmospheric Research for the Antarctic campaign, and a Falcon 20 provided by NASA Langley Research Center for the Arctic. Going with smaller aircraft represents something of a scientific trade-off, as they can survey more area, but carry less of a payload.
With other IceBridge campaigns, which typically use larger aircraft than the Langley Falcon behind us, we put a lot of instruments on, a dozen or so instruments. Because this is a smaller platform, a more limited scope of operations, we're only putting two major instruments on board. That's the Airborne Topographic Mapper and the Digital Mapping System. Both are optical instruments. The first one, the Airborne Topographic Mapper, or ATM for short, is a scanning laser altimeter. And what that does is it fires out several thousand laser shots every second. And we also measure the position and the orientation of the aircraft and the direction in which the laser shots are exiting the aircraft. All those things are measured very accurately, very carefully. And that lets us assign, once we do all the measurements, that lets us assign a latitude, a longitude, and a height to the spot where each one of those laser shots bounces off the ground, off the ice in our case. And that lets us build up a very, very detailed and very accurate topographic map of a swath of measurements beneath the aircraft. The digital mapping system supplements that. It does some of the same kind of stuff, but it does it in a passive manner. It's really a very fancy camera. It's not a bad way to think about it. It's a photogrammetric camera, so in a similar manner to the ATM, you can assign a latitude, a longitude, and an altitude to every pixel within every image that comes back, and the images are shot about once every second.
The Antarctic campaign will also feature the DMS photographic system and a laser altimeter called Elvis.
So Elvis is a high altitude laser altimeter system. It flies at about 10 kilometers above the surface, and we have a 2-kilometer wide swath. And we measure the topographic information within that swath, as well as the three-dimensional surface structure. And that's very useful for measuring and monitoring ice sheets, where repeated measurements can tell you whether the ice sheet is growing or shrinking over time, and its contribution to sea level. We have a series of lines that are distributed across the West Antarctic ice sheet and the peninsula, as well as over the sea ice that's in the Weddell Sea and the Bellingshausen. The flights that we will be doing will be 10 hours long. We take off from Punta Arenas, which is in the southern portion of Chile, and then typically a 2 to 5 hour transit, depending on where we're going in Antarctica.